We've got this and then one more little drill on exponentials that we'll do Friday.
Then we're done for the year.
No. Almost though. Not much longer. We just gotta get through May, right?
Do what?
We just gotta get through May. April and May.
Yeah, I still too long. Good night. That's all. My brother. I'm not getting before finals.
So the only reason why I like it, she's one of the golf cart.
How fast do you want to go in a golf cart?
Listen,
You ever seen Cletus Farley? He's like a 1,000 cc.
He's never seen Clayers.
1,000 cc bike.
It's kind of dangerous.
It's a little bit off.
No, it's per
Power here.
That's
Golf cart.
specifically how.
Like 900 pounds and have like 40 work. 400 work. Okay,
We'll see if like that 200 power. What is that like?
yeah, you know what's you ever seen a rocket ship?
You guys ready to start?
No.
No, not yet. Give us like 20 more minutes.
No. I want to get through this.
Good cheese.
Yes.
How many questions is this one?
15, I believe. 3 sets of 5.
A what?
I know what to do with golf cart.
Is this one hard? Probably.
No, I don't think so.
You know,
This one is the one that I made those 3 videos for.
No, the side.
dude, no, you really need things on like let's be honest.
Yeah.
No.
Yes, because the engine is mounted right underneath the seat. And the seat.
Exactly. So just just plumb it.
This is exponential functions.
You just have like a downpipe.
There's no downpipe.
Like literally just
Just
like,
have a downpipe that like
Yeah.
just barely sticks out.
yeah.
You know what I really want to do? Is I want to get a couple of these. Oh, these aren't first ones. I want to full bucket.
Dude, you guys yell at cops yesterday on round 2? Or was that during one of the drove on round 2?
I was in there at night, but I wasn't.
I saw 3. I saw 2 state police officers and another cop.
I need a flyers. I only got a couple of these. And stick them, put them on the keys. So you just
kind
kind
of
of
break you next.
so you can, so this is so you can't fall off. Full container
Yes.
seats.
Yeah.
Okay, we'll start with question 1.
Dude, imagine being in a fight.
Hey, you get a 5-point furnace, then you can have a removable steering wheel.
Okay, guys. Quiet. All right, we're going to start with question 1. Are you guys ready?
Yes.
Okay. You two quiet.
Exponential function.
Tyler, you got to sit as well.
Do I know?
Yes.
Are we exponential function?
Yeah. So these are 15 questions. You got 3 sets of 5. The first 5 kind of all are the same. The second 5 all are the same, and the third 5 all are the same. These have the videos that go along with them, but I'll go over them now, just like I did in the videos. There are basically equations that go with these, and you kind of just plug things in, but it's good to understand what each part of the, I should say, formula, what each part of the formula means, so that way it's easier to set up on your own. Okay, so the first question is: a population increases at a factor of 3 per 13 units of time. So what we have here is exponential growth. A very common one is like doubling. So let's say every unit of time something doubles. So in the first unit of time you have 1. So you have 100% of what you started with. And then the next unit of time after, let's say it's an hour. Unit of time just means some amount of time. It could be an hour, it could be a year, it could be a month, whatever the doubling time is. In 1 unit of time, you would double to 2, and then in another month or so, you would double again, so you'd then have 4, and then you double again, then you have 8 for every unit of time. In this case, it's a factor of 3, so it's tripling every unit of time. And the unit of time is 13. Okay, it is estimated that the population in 2000 was 275, so we're starting with 275, and it's going to triple every 13 units of time. So in this case, a unit of time seems to be years, because if you read part A, it says, find the function that models the population t years after 2000. So if t is 0, that means there's 0 years after 2000, so that means the year is 2000. If t is 1, that means 1 year after 2000, so then it's 2001. So t just tells you how many years after 2000. T equals 0 means it's the year 2000. In the year 2000, we had 275 in our population, and every 13 years, it's going to triple. So we need a function that goes with that.
My question does not match that one at all.
Are you on
Number 1.
exponential functions?
Yes.
What is your
percent?
percent?
It's not units.
Really?
Yeah, I think that's like, it's somewhere in there. The percentages.
Are you scrambled or something?
I think it scrambles them,
Oh,
no matter what.
okay. Maybe it does scramble them. Why don't you move to a question that looks like number 1 here? There should be 5 questions that resemble number 1. So there should be a factor that it so it should say increases. It should say by a factor of some number per some unit of time.
None of mine are this.
Let me see.
And I only have 14 questions.
You're on exponential equation.
Yeah, you want exponential function.
What? This one, wait.
Yep.
Oh.
Okay, so here's the formula that you're going to use. You're going to find that it's kind of like what we had before. Before we had compound interest, where the amount was the principal times 100% plus the rate divided by the number of compoundings. We had this formula where you had a power that got multiplied. This factor got multiplied for as many compounding events as you had. It's very similar to that, only this time we're going to have an amount that's equal to your initial. I'll write it a little differently, actually. I think this is the way I did it in the video. So your population as a function of time is your initial population. We call that P0. Yeah. So that means at time 0, that's your initial population, times some base growth factor. I'm just using B as the base of the power, raised to some unit of time. So that's our exponential equation. However, if you don't get multiplied by that base factor until 13 units or until whatever the period is, you're going to put that down below. So this is your time to increase by a factor of B. I'm going to use different colors maybe here just to make it a little easier. B would be the factor you increase by periodically or at regular intervals. So, and then T is the amount of time that's passed. Maybe I'll use green for the initial. So that's your initial population size. And then T, I'll make that black, I guess. Amount of time passed. And that's your variable. So in this first case, they just want the function. So they want you to fill in all these quantities with the information that they gave you. But they want it as a function of time, which means you're going to leave T as a variable. So you're just going to plug into this thing. So what's my initial population size? Well, P as a function of T will equal the initial population size, so 275. T is going to be a variable. My factor that I increase by is 3, and I do that every 13 units of time. So my numbers are 275, 3, and 13. So P is a function of T. My population as a function of time is equal to the initial population. That's 275. I'll put that in green, I guess, just to be consistent. 275 times 3. So I'm going to triple every 13 units of time. So T over, and in this case, 13. So when T becomes 13, after 13 years, my exponent is 13 over 13. That's 1. That means I multiply by 3 once. So I triple after 13 years. In 26 years, the exponent becomes 2. So I multiply by 3 twice. I triple again after another 13 years. So you always put the amount of time it takes to triple underneath the variable like that. That's it. That's your function. You're just plugging in 3 numbers here. And when
it just seems complicated.
It's a little complicated. Really, this is your growth factor. You triple how many times? Well, that depends on how many units of 13 you go, because every unit of 13 gives you another times 3. So you really just got to plug in the growth factor, the time it takes to grow by that growth factor, and then out front just goes your starting amount. So once you have this formula, you just plug in for these first 5 questions. You just plug in for that first part, leaving T as a variable. In the last part, you plug in however many years have passed, and you calculate what that is. So as you can see, that's what they have here. It's 275 times 3 to the T over 13. And you're going to do that for the first 5 questions. You're just going to plug in those values. In the next part, they say, okay, estimate the size of the population in 2006. Well, T represents the number of years after 2000. So 2006 is 6 years after that. So T would be 6. All you do is put this into your calculator, plugging in 6 for T. So you'd have to raise 3 to the 6 over 13.
Why would you put 6 in?
You would, depending on your calculator, you would put 3 caret, raise it to the, and then parentheses, do 6 divided by 13, close parentheses.
Yeah, but where did you get 6 from?
They want to estimate the population in 2006. So if t equals 0 represents 2000, t equals 6 would represent 2006 because it's 6 years after 2000. So however many years after 2000 you're looking at, that's going to be your t. So when you plug it in, you're going to get a decimal. They want you to round it down to the nearest integer. So in this case, we got 456.
I got mine wrong, the bottom one.
Did you round down?
Round down?
Yeah.
What does that mean?
So if you got 456.1, you'd do 456.
Yeah, but I got 908.6, so I did 909.
You want to round down.
So 908,
Yeah.
still got it wrong.
What's your function that you did for the first part?
380 times 5 and t over 23.
Like this?
Yes.
Okay.
And then the
So
population of the year was 2011, the second one.
so you got to put in 11 for t.
Yeah.
Okay. So so you had 5. I need to go to scientific here. So 5.
Do I need to do that?
Well, let's make sure that we're getting the same thing. Yeah, so I'm going to put in 5. I'm going to raise it to I'm going to do a parenthesis. 11 over 23, did you say?
Yep.
So that gives me that. And then I'm going to say times 380. So 820.
Yeah, that's right.
Okay, let me see. Maybe
Can I put mine in second and then in scientific?
I don't know what you did. No, you want to just round it down to the nearest integer. Oh, in your calculator, you mean?
Yeah.
No, you already have all those buttons. My calculator just didn't have all the buttons because I was in standard calculator mode. You have a scientific calculator.
Do I put it in scientific though?
No, that is a scientific calculator.
Because it has like different modes and it says flow, scientific, and
Yeah, that there's floating numbers, there's scientific notation and engineering notation. That's different. A scientific calculator just has like the trig buttons, like sine, cosine, tangent. That's what they mean there. You've already got all the buttons. I just didn't have all the buttons on mine. Is that okay?
mm-hmm.
All right, the next couple of questions are the same. Well, the first 5 questions are all like that. So it tells you the growth factor that it increases by, the units of time, and the starting population. That makes your function for part A. And part B, you just plug in the number of years and calculate it and round down.
Is question 6 different?
Yep.
Okay.
You guys ready for that? Let's move this over here. You got the numbers right for the other ones?
Yep.
Okay. Yeah, question 6 will be different. So we're decreasing now. The only difference here, there's a couple ways that you could do this. There's 2 ways that you could do this. So here we're decreasing. That's the main change that you should notice. A population decreases at a factor of 4 per 24 units of time. It started with such a big population. Give it as a function, and then what happens after so many years? Where you round down yet again. Okay, so here's what we had before. So I have my initial population, right? Times the growth factor, which in that case we were growing, raised to a power, which was the amount of time divided by the amount of time it takes to change by that growth factor. Right? Well, exponentiation means you're repeatedly multiplying by the growth factor based on what the exponent is. In order to decay, to shrink instead of grow, you're not going to multiply, you're going to divide. And the way to represent like a multiple of divisions rather than a repeated multiplication, you want to do repeated division. There's a couple ways you could do that. Either, let me clear the bottom here. I'll choose a different color here. I'll choose this orange kind of color. All right, and here's where the changes come in. Instead of increase, we're going to decrease. The factor that you decrease by periodically. And pretty much everything else is the same. All I have to do to get this to work is make this exponent a negative. And that will handle decreasing. So everything else can remain the same, but you could just put in a negative up there. That's one way to do it. So this would handle decreasing. Another way to do repeated divisions, instead of using a negative, I could write, I'll do this again. So P is a function of T is equal to the initial population times the growth factor. So I'm actually going to do 1 over the growth factor raised to the T over the period. So these are both good ways. This one I think is the more standard down here, but a negative up here would be the same. So you could just put a negative up top. That's one way to represent decreasing. Or when you do your factor, your growth factor, just do it as a fraction, 1 over that growth factor instead of just putting the number there. So I'll plug in now what I have. So in my case, my factor is 4. I'm now going to not multiply by 4 every so often. I'm going to divide by 4. I'm going to take a quarter of what I have. And because I'm decreasing. 24 is the unit of time that this happens in, and my initial population is 595, 465. So I'm going to say E of T is 595, 465 times 1 over 4, because I'm decreasing by a factor of 4, And then I'm going to have t over, what was it, 24? Yeah, 24. And so it's exactly like I had before, except I'm dividing by 4 instead of multiplying by 4. So I could either write it as a fraction like this, or I could put 4 here with a negative. Either way is the same. I know that they have it written this way in the answer key, so I guess I'd go with that. But they're equivalent. I could have just written 595 or 65 times 4 to the negative t over 24. That's the same thing as what I have down here. They do the same. So negative is the same as 1/4. So that's what you put in. So it's just like before, only, you plug in your initial population. Your growth factor is now division instead of multiplication to show that you're decreasing. And your exponent is just the same, t over the period of time that it takes to take a quarter of your population. And then you'll just plug in 10 for t in this question because they want to know that in the year 2010. And if you round down, you should get that as your answer.
So because you're making the 4 a fraction, you can take away the negative on the.
Yes, yeah. Either the negative means to divide instead of multiply repeatedly.
Mm-hmm.
So you could do 4 to the negative like this. Or you could just say 1/4. That way, when you repeatedly multiply, you're multiplying by a quarter. So you're actually dividing by 4.
And you plug it in again just like that?
Yeah, just make sure you have parentheses around the 1/4.
Mm-hmm.
And I'd put parentheses around the exponent.
Or like on the calculator, how do you make like a fraction? You just put the division?
Yeah, just use division.
And then you multiply that by the big number?
Yep. It should be smaller now. Before we were doing exponential growth, now we're doing exponential decay. It's pretty much the same thing.
And are these gonna be for a couple questions now?
Yeah, there's 3 sets of 5 questions, so 1 through 5, 6 through 10, 11 through 15 will all be different sets.
What's like the last section gonna be?
Are you ready for that?
No, I just was wondering.
It's exponential growth again. It's kind of like this up here. Just there's a little bit of stuff to figure out with this, the growth factor. It's how you work when they tell you about it grows by a certain percentage of a unit of time. But other than that, it's pretty much like the first 5.
Do we, if it's like a factor of 5, we put 1/5, right?
Yeah, you
It
could do
doesn't
one.
matter if it's like.
Yeah, you could do 1/5.
Okay.
Can I go to the bathroom?
Yes.
I'm ready.
Okay. Okay. So the next set of questions is, I think they're all exponential growth. So they're like what we had before, like this, without the negative there. But instead of a base rate being like 2, 3, 4, 5, the base rate is going to be a percentage. So I'm going to clear all this.
So we have to make that percentage of
Yeah.
a fraction.
So, okay, say that they say there's a population with a growth rate of 7%. They tell you the initial population. And So they're saying per year. So in this case, we don't need to divide the exponent by how many years it takes to increase by this factor, because they're telling us per year. So we don't have to worry about that. So now we're just going to say, they're saying 7%. So the initial population is 29,500, I think. The base rate, did they say 7%? Let me check.
Yeah.
7%. So all we got to do is say, okay, my growth factor is 100%. I'm going to keep my initial population, but I'm going to increase by an additional 7%. So I'm going to add to 1 0.07. And then I'm going to raise that to the number of years. So that's going to be my function.
We still have to put T over, or
No, it's going to be over 1 year, so you don't really have to do that. Divided by 1 doesn't affect it. So
we don't need to put an
if
exponent?
they said it increased by 7% every 10 years, then I would have to do this. But they're saying per year, so
We don't even have to put like the 1
no.
or T.
You'd have to put T. Yeah,
Okay.
you need the function. To be a function, you need a variable.
So then what do you do when you plug it into your calculator?
You're just going to raise it to the number of years. So in this case,
Just 1.
for 8, I have 8 here. So 8 years after 2000. I'm just going to say 1.07 raised to the 8th times 29,500.
Okay.
Easy? Good. I think they're all like that. So
Per year.
yeah. So my next one's 4%, so I'd use 1.04. Everything else the
Can I
same.
just give you mine so we can?
Yeah. Ugh. How are you?
It's hotter than Kelly's oven in here.
It's cooking.
How's it going?
Good.
I'm recording this. We're going over exponential functions. So this is the homework that we had those 3 videos on the classroom for. So you can look at those, or you could follow the video that I'm making now. You have an appointment?
Huh?
Did you have an appointment?
I had a migraine this morning.
Oh. Feeling better?
Yeah, a little bit.
Can I give you mine?
Let me see if it's working. There it finally goes. Yeah, so your population will be your initial population times, 1 plus the rate of growth raised to the number of years. So yeah, go ahead and give me your numbers.
Okay, so population is 20,700. And then the percent is 1.08.
So 1 point,
No, like it was 8, but I just
Oh.
sorry. Yeah. And then
yeah, T.
and then it's per year.
Yep.
Awesome. Yes.
And then what year do they want?
2008.
And you're gonna round down.
Okay, so that's true.
Yes.
there.
Is this making sense?
Yep.
Good.
I just forgot to plug in the first one.
That's what I missed. Thinking about it. Holy cow.
Got it right.
Good. Should be like that for all of them. So you'll notice that this is just like the compound interest when you used to do this.
Spanish versus there. Those other.
Are we going over the exponential equations next class then?
Yeah.
Okay. What? Did you say something?
I said yes.
Okay.
Yeah. Some of them are like what you were just doing. Some of them are like the compound interest. And then some of them you're solving, what value makes this. So we'll go over those together.